Alrighty, so these are some of the pH example problems I was going to show you in the Zoom yesterday, but then my internet crashed, and so hopefully these will help you correctly understand the answers to the assessment for pH and pOH. So here's a commonly missed one. It says, what will be the concentration of hydroxide ions in solution with a pH of 4? So here is where people are getting screwed up. Hydroxide, they're asking for the concentration of hydroxides, not the concentration of hydrogens, which is what the pH indicates. So if I've got a pH of 4, that means that my concentration of hydrogens is going to equal 10 to the negative 4th. Now, I told you in the slideshow that the concentration of hydroxides plus the concentration of hydrogens in a solution always has to add up to 10 to the negative 14th. So what this means is if the hydrogens are going to be 10 to the negative 4th, it has to be the case that the hydroxides are going to be 10 to the negative 10th. And this is multiplied. I did a plus sign, but oops. So with that being said, I now know that my hydroxides are going to have a concentration of 10 to the negative 10th. There's a couple problems like that on the quiz where you're looking at the hydroxides rather than the hydrogens. Here's another one. Commonly missed problem, when the pH of a solution changes from 12 to 9, what is the change in hydroxide in the hydroxide concentration? So everybody who answered this said that it would be 1,000 times more, but because it says hydroxide here, it's actually 1,000 times less. So you did a really good job of recognizing that if you go from 12 to 9, you're going from 10 to the negative 12th in terms of your concentration of hydrogens to concentration of hydrogens being 10 to the negative 9th. So that's true. This is going to increase the concentration of hydrogen ions, which means that my concentration of hydroxides here would be 10 to the negative 2nd. And in my new case, my concentration of hydroxides would be 10 to the negative 5th, 1,000 times less than what the original amount would be. Because I'm going from 10 to the negative 2nd to 10 to the negative 5th. So again, that hydroxide stuff just kind of tripped us up. Here's another commonly missed question. It says, which solution will have the lowest pH? So most of you chose that you would have this particular solution of ethanoic acid have the lowest pH, which would be a strong acid. The lower the pH, the stronger the acid. However, notice here, I got hydrocarbon. Hydrocarbon indicates weak acid. That means that equilibrium will lie to the left. That means you will not get a high amount of dissociation with this acid. That means your pH is going to be higher. Sulfuric acid is going to be a strong acid. And even though these concentrations are the same, more of the sulfuric acid is going to dissolve into water, and that's going to lower the pH and concentration of hydrogens. So that's why the answer to this one is, I guess that would be like a C. And then the grand finale, the pH stoichiometry problem. So it says, what volume of 0.0200 moles per liter sodium hydroxide solution must be added to 25 milliliters of a solution of hydrochloric acid with a pH of 2 to produce a solution with a pH of 7? First and foremost, it says here pH of 7. That means I'm neutralizing this. All of the acid is going to neutralize all the base. So I want to figure out how much acid I need to add to this much base in order to get a neutralization. You might remember a couple weeks ago, these little charts that I set up, CVN, and I know my HCl, and I don't know my NaOH. My goal is to figure out the volume of NaOH. So let's look at the HCl. I know my volume is 25 milliliters, or 25 cubic centimeters. I'm going to change that to liters. So it's going to be 0.025. And it's not intuitive that I've got the concentration, but I really do. Strong acid, 99.999% dissolves into water. So if I know I've got a pH of 2, I know that I've got a concentration of hydrogen ions that's going to be 10 to the negative second moles per liter. So I do know a concentration here. Likewise, on this side here, I've got sodium hydroxide that has this concentration. And I'm looking for volume. And now my common denominator here is moles. Quick balanced equation. You've seen this one a bunch of times. Here's stomach acid, hydrochloric acid, sodium hydroxide will go to water and salts. And it's a 1:1:1 ratio. So however many moles of HCl that I have here will be the same number of moles of sodium hydroxide I'll have here. So I'm going to come over here to my HCl and say C equals N over V, or CV equals N. Concentration is 10 in the negative seconds. Volume is 0.20250. And I'm going to solve this out. And I get my number of moles to be 0.00025. And everything's with 2 sig figs here. So my number of moles here is 0.00025. So my number of moles over here with sodium hydroxide is also 0.00025. So now I'm ready for my last step. I'm going to come over here with C equals N over V. And I know that the same number of moles of sodium hydroxide will react with the same number of moles of HCl because I have a 1:1:1 ratio. If this was different, if this was like H2SO4, I would have to do an extra step to get the right number of moles. In this case, I do not. And I'm going to say that N over C equals V. And the 0.00025 divided by your 0.0200 is going to be my volume. Solve that out. And my volume is going to be 0.0125 liters. Move that 1, 2, 3, 12.5 milliliters. And I don't remember what answer that was on the multiple choice quiz, but I do remember that is the correct answer. So the trick is, it's a solution stoichiometry problem. The only additional step here is to recognize that pH for a strong acid just indicates the concentration of hydrogens. So hopefully this helps. Oh, I want to talk about one more thing here. Sig figs. When we're doing sig figs, we don't pay attention to the sig figs in the pH or the pH of neutralization or the pH of the acid. And that's due to it being a logarithmic scale, and that's actually not going to be a measurement that you have to take into consideration. When we're doing these problems, we're taking in these sig figs for that you find in the measurements. So it'd be the 0.0200 to 25.0. So there you go. Hopefully this helps out.